This is Algebra 2, problem 2-18. In these problems, we are to solve for the variable that's in the exponent. But the problem is the left side base and the right side base are not the same, so we can't get to these exponents. So that is our goal here, is to get our bases the same. So I notice that 4 and 8 can both be written as a base 2 number. That 4 happens to be 2 to the second, and 8 happens to be 2 to the third. So I change them each to their base 2 numbers. And simplifying, now that the bases are equal, I know that their exponents are also equal. So therefore 2z equals 3, and I've got the answer z equals 3/2. Our goal in the next problem is the same thing. I've got a base 4, and I have a base 8. I'm going to change them both to base 2. And I have their original exponents, 2z over 3 and z plus 2. We now need to simplify by multiplying these exponents on both the left and the right. And since the bases are the same, their exponents are equal, and we go through and we solve for z. In problem C, I have a base 3 and a base 81, and I can write those both as base 3 numbers. Well, 3 is already a base 3, but 81 is 3 to the 4th. And so I now simplify those exponents. Their bases are the same, so their exponents are equal, and we solve. In part D, we've got a base 5 and a base 25. I'm going to change those both to base 5, and then I'm going to simplify those exponents. And since they're both now base 5, I know that those exponents are equal, so we solve. To solve those, we will cross multiply. When we do that, we end up with a quadratic. And to solve a quadratic, we want it to equal 0. So I subtracted 6 from both sides, and now I have this quadratic, which we can factor. So I've got these two factors, z plus 3 and z minus 2, and therefore z equals -3 or 2, which is the final answer.